So here's a question that I wanted to take on. The question is pretty simple, yet could be confusing for some people, especially the beginners. Uh, I'll just go on and brief some details about the questions and the way to get it more intuitive in terms of analyzing and solving this. So fairly straightforward. Two men, five boys can finish a piece of work in 4 days, while three men, six boys can finish it in 3 days. Find the time taken by one man alone and one boy alone to finish the work. Uh, Fine. Let's understand this concept of work a little bit. Probably that could be the beginning of solving these kinds of questions. So, when we say work, that work could be anything they have not explicitly mentioned. Uh, we don't know. So, the multiple forms of work, but it's something that is doable, and some bunch of people are completing it. So, that could be anything. That could be cleaning up a particular floor, or building castles, or making a road, or whatever. We don't know that, right? So, there is an essence of completion of work that we can see from this problem. Completion of work. Okay. So some people are working on it. Some people are contributing for completion of work. Okay. Uh, so at this point itself, let's denote this completion of work by some parameter. Let's say a work is set to be completed when 100% of it is done, or 100 is completed, right? So complete work means what? A complete work or work can be said to be completed if 100% of it is done. So complete work contributes to 100. I've just given a way to express completion of work, right? Complete work means 100. Okay. So when we say the work is completed in 4 days, what it essentially means that in 4 days, this 100 units or the 100% work is done, right? 100% work is completed. Similarly, if let's say we need to know how much work is completed in one day, work completed in one day. The work completed in one day would be, what is the total work, that is 100, and how much time it took to complete this, 4 days. So the work amount of work completed in one day would be 100 upon 4. One fourth part of 100, right? One fourth part of the complete work. And that would be just 25. So 25 amount of work is completed in one day. Okay, just divide the number of days to the total work. Okay, the total work divided by the days gives you the work done per day, right? The work done per day. Let's generalize this. If, let's say, the complete work is denoted by W, again, I've just thrown a letter, doesn't matter. So if complete work is denoted by W, uh, then if it takes X number of days to complete this W amount of work, then then essentially how much would be the work done per day. So that we can find as the amount of work done on a single day or per day would be just this total W upon X, right? This total W upon X. So we are trying to find out the work done on a single given day. Why so? Because I just want to tell you to make a procedure where you can convert the entire work into something which is doable in 1 day time frame. That would just make the solution of the problem a little bit easier in that manner. So this is something which has been done per day. Okay. So let's say the work was to uh, I don't know, decorate your house for a house party. Okay, so that is W. It took, let's say, 10 days to decorate the house for house party. So the work done per day would be W upon 10. So 1/10 of a work was done per day. So 10 days together completed the complete work W. Okay, right. So in that manner, we can further proceed the question. Uh, the question says that two men and five boys can finish a piece of work in 4 days. So certain work is there which is completed in 4 days. I'll just mention the complete work as 100 because it makes a more intuitive appeal to it, like 100% of work is completed. We are habituated to say that. So I'll just consider 100 as the indicator of complete work, right? So let's say complete work denotes 100% or 100 units, right? 100 units means the work is completed. Okay. Now, the question says 4 days it took, as long as 4 days it took to complete this 100 units of work. So then ask yourself, how much work would it complete in a single day? In a single day, in 1 day, how much of the work would be completed? That's simple then. That is just 100 divided by 4. Just 100 divided by 4. Right? Yeah. Similarly, they have also extended uh, the question saying that blah 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 can finish the work in 3 days now. So we can do the same thing here as well. Uh, when it comes to 3 days time period, if 3 days are required to complete this 100 units, 1 day would complete a work of 100 upon 3, right? 100 upon 3 or 1/3 of 100 work would be completed in 1 day. And here 1/4 of the 100 work would be completed in 1 day. Fine. So you may think on this and ask a question, why different days, why different amount of work has been completed in given day, or conversely, in one scenario, 4 days are required to complete the work. In another scenario, just 3 days are required to complete the work. What magic is happening here? Well, that magic lies in this fact that the amount of people contributing to work are different. Here, 3 men and 6 boys are contributing to the work. Here, 2 men and 5 boys are contributing to complete the work. So, somewhere the lack of manpower is what is increasing the number of days, right? Okay, fine. So this is all hopefully making sense. Okay, now let's extend the question. The men and the boys are essentially the resources for completing the work. And often in these kind of question, you'll always see some sort of resources for completing the work. Right. So in this case, the men and the boys are doing that. So, in such questions, the work is completed by some resources. Of course, it won't complete magically, neither do we have some AI to complete it. Anyways, AI is also a resource. Yeah, so a human-like resource needs to complete it. Uh, so in this case, in our case, the men and the boys are those resources. So the men and the boys form the resources to complete the work, right? So some number of men and some number of boys will together do the work. They'll contribute in completing the work, and finally they'll complete it. The interesting fact about these resources are these are unique, and these have their own rates of completing the work. For example, the men could work faster, the boys may work little sluggish, or vice versa. We don't know. So essentially, there is some rate at which the work is being done by the men, and there is some rate at which the work is being done by the boys. And there are different rates. Doesn't need to be the same. One might do faster, one might do slower. We don't know what that rate is, right? Generally, we assign this rate as the variable in the question. So let's call the rate at which a man can do the work per day as X, and the rate at which the boys can do the work per day as Y. So we get the two variables. Let me explicitly mention these two variables uh, so that it is clear. Let X be the rate at which a man can do the work per day. You can also call it as, you can also reframe this as amount of work that a man completes per day, right? So amount of work that a man completes per day is X. Similarly, Y represents the rate at which the work is done by the boy per day, which can also be reframed as amount of work that a boy completes per day, completes in a given day. All right, so X being the rate at which a man has completed the work, and Y being the rate at which the boy has completed the work. Now, let's see the resources and let's see what is the thing. In the first statement, it is said that 2 men and 5 boys can finish the work in 4 days. Okay, so we have 2 men and we have 5 boys finishing the work in 4 days. Well, at this point, let's take everything on a per day basis. Let's take everything on the per day basis and let's ask ourselves how much of the work is being done per day. That we have already calculated. It is 100 upon 4. Okay. Then let's ask ourselves how much is the amount of work that is done by 2 men on that given day. 2 men have done the work as, as per as their rate for that day. What I mean is, two men are doing the work, how fast they can do. They can do the way their rate has been decided. That rate, that speed at which they can complete the work is right here, x. So 2 multiplied by x is the amount of work done by two men on a single day. Okay. Similarly, for 5 boys, it is 5 multiplied by y. This tells us amount of work done by 5 boys on a single day. Okay. So, men are doing some work on a single day, that is 2x. Boys are doing some work, that is 5y. Together, they give a complete work of 100 upon 4. That is the share of work per day. And this right here becomes our first equation of the problem. 2x plus 5y is equal to 100 upon 4. 2x plus 5y is equal to 100 upon 4. Similarly, with the same logic, we can construct yet another equation considering the second statement of the problem. 3 men and 6 boys finished it in 3 days. So, 3 men multiplied by the rate at which they can do the work plus 6 boys plus 6 boys multiplied by the rate at which they do the work per day is equal to 100 upon 3. This becomes the equation number 2, right? So we have this equation and we have first equation. Now it is fairly easy. We can solve these are two linear equations uh, of two variables. We can solve them. We have two variables here, x and y. We have two equations, so pretty much solvable. We can find the values of x and y. X and y would give us the rate of work that a man can do and the rate of work that a boy can do, right? So pretty simple. Let me just quickly do it. uh, 2x plus uh, 5y is equal to 100 upon 4. This is the equation number 1. We can do elimination, we can do all sorts of things to solve them. I'll just do some elimination thing to get it solved. So I can multiply the equation number 2 with 2 and I can multiply the equation number 1 with 3 uh, and then I can subtract them both. So the equation number 1 I will write first. So it will become 6x plus 15y is equal to uh, 300 upon 4 and the equation number 2 would become 6x plus 12y is equal to uh, 200 upon 3. The reason that I've done this is to get 6x and 6x common here, which can be eliminated after subtraction. So after subtracting these two, the value that I'll get is uh, 15 minus 12. So that becomes 3y is equal to 300 upon 4 minus 200 upon 3. Right. Let's just simplify this further. Y becomes 1 by 3
300 upon 4 minus 200 upon 3. That should give me 100 upon 4 minus 200 upon 9. There you go. The value of y that we get is 100 upon 36. So 100 upon 36 is the rate at which a boy can do the work. Right? This is the amount of work that is completed by a boy per day. And if you look at this carefully, it is 100 upon 36. So 100 here represents the total work, and 100 upon 36 represents a fraction of total work. It represents a fraction of total work. And that is how it should be, because it is the work done on a given day by one of the resource, that is the boy. In real case, boys and men together are completing that work. So some contribution by the boy per day and some contribution by the men per day, right? So once we have this, we can also calculate the contribution by the men. We can put y in any of these equations and we'll get the value of the contribution by the men. So let me just put it in equation number 2 probably, because I can say C6 there. Put value of y in equation 2. So that would make this equation as, this is the equation 2, 3x plus 6y. 3x plus 6. In place of y, I'll write the identity of y now. And upon 3. Let me just quickly solve this to get the value of x. Right. So this is the value of x. Find that this is the contribution of the men in doing the work. So 100 being the total work, and this whole is representing some fraction of that work. Remember, x is here 100 upon 18, and y that we have gotten was 100 upon 36. Which one is greater? We can clearly see that x is greater than y, right? So the rate at which men can do the work is more than the rate at which the boys are doing the work. So amount of work done by the men is more than the amount of work done by the boys. To give you the visualization of this, I'll just calculate this fraction out. So 100 upon 18, that becomes 5.5 pi, right? And 100 upon 36 is 2.77. Okay, so 5.55 units is the work done on a given day. On a given day, good sunny shiny day, the man has done a contribution of 5.55. The boy has done a contribution of 2.77. And what is the day's contribution for the work? The day's contribution for the work is 100 upon 3 for the first condition, first day. All right, so this is still, we have to multiply it with number of men and women. But anyways, so this is the amount of work contribution by a man, amount of work contribution by a boy. Now, let's consider the scenario one. In scenario one, what is happening is, if you see the first sentence of the question, two men and five boys are completing the work, right? Two men and five boys are completing the work. So two men, so 2x plus 5y is equal to 100 upon 4. We have to consider this equation. Now 2 multiplied by 5.55, which is the rate per day, plus 5 multiplied by 2.77 is equal to 100 upon 4, that is 25. So how much is this value? This value is 2 multiplied by 5.555, it becomes 11.111, plus this value is 5 multiplied by 2.77, it becomes 13.85. If you just add them up, yep, it becomes almost equal to 25, right? This is the contribution from the two men, and this is the contribution from the uh, five boys. Some work is done by the men, some work is done by the guys. Although the rate of guys is less, that the amount of work that a boy can do is less, but number of boys are more. So combined, the total work contributed by the boys is little greater than that of the men. Contribution from men, and this is contribution from boys, right? Some contribution from men, some contribution from the boys, together completing the day's task. The day's task was to complete 25 units of anything, right? Whatever that work is. Okay, fine. So enough of this explanation. What we wanted in answer is what we have already gotten. We wanted the value of x, we wanted the value of y. That we have found out. However, the question asks us to find the time taken by one man alone and one boy alone to finish the work. The question is asking something different. We have calculated the rates, but the question is asking us little extra. It's 100 upon 18 and 100 upon 36. 100 upon. Right. So 100 upon 18 is the, again, amount of work done by the man per day. Right. So in one day, the man can do 100 upon 18 work. Remember, 100 being the total work. This is the total work. Okay. So 1/18th of the total work is done in one day. In second day, again 1/18th of the work will be done. Third day, again 1/18th of the work will be done. Right? So one day, second day, third day, fourth day, fifth day. Every day that person is coming and doing 100 by 18 work, 100 by 18 work, 100 by 18 work, and so on. So we should ask ourselves, at what moment will the work will be completed? So it is very simple. One day, 100 upon 18. So how much days will it require to complete the total work? 18 days, right? One day is contributing 100 upon 18. Then just cross multiply, we get 18 days to complete the 100 work, 100 units of work. 100 units of work will be completed in 18 days. Don't think about this mathematically, think logically. 1/18th of a work is done, sorry, total work, 1/18th of total work is done. So how much days will be required? 18 days, right? If it was 1/50th of the total work done one day, the total work would require 50 days. This is simple, right? Yeah. So what can we conclude with this? We can conclude that a single man would take 18 days to complete the work if he does it all alone. If the man is the only person in charge of completing the work, in that case, he would complete it in 18 days. Similarly, for boys, in one day, how much of the work is completed by the guy, by the boy? It is 100 upon 8, 100 upon 36. So, how many days required? Days required to complete the 100 units work. The days required would be 36, right? 36 days. And that's it. Therefore, we can directly say that the boy requires 36 days to finish up the work. And that is it. That is how we should tackle this question. And once enough practice is done, this whole process will come automatically. No need to spend so much time in solving this. But for physical understanding, yeah, we probably need to go through this in a larger depth in the beginning, beginning few exercises, beginning few problems. But once the procedure is understood well, the questions can be solved very, very easily. I hope this was helpful. Thank you so much.